The Persistence of Vision uses an Arduino Nano to control a dual alphanumeric display. It does this with the assistance of two shift register ICs, which can convert 5 input pins into the 14 outputs needed. The 5 input pins are the first, the data pin, which provides the shift register with what information you would like to output. Then there's the output enable pin, which is set to low before each shift out to prevent ghosting on the display. The last pin, which is helped to copy the data from the input pin to the 8 output pins. Then there is a clock pin, which times the copying the data within the IC. And in this case, there's also a pin used to daisy chain one shift register to the other. Lastly, the square wave pin, which is also used to provide an oscillating signal to the square wave generator, which times the alternation between the two sides of the display. The outputs from the two shift registers are taken through 4 resistor networks before being connected to the respective segments on the display. Arduino, which is displayed on the 14-segment display. This data from the Arduino, in combination with a clock and latch pin, is to tell the shift register where and how they understand the oncoming data. This is all that is needed to help the chip, which needs to output 8 different pieces of data, which then goes to the display in order to display a word. The clock pin also works as a type of timing mechanism for the chip. The way this clock pin works is that it only will display an output 0 if the clock pin has a high signal and the data pin has a low signal. But if the clock and data pin both have a high signal at the exact same time, the data will then have a high signal, which in case outputs as 1. The data pin is also used as a free space for the chip, because when loading data to the chip, it will then accept new information and overwrite that previous data that I got. But when it gets sent, that data pin gets sent a high signal, which will then release of that data's various output pins. In the top right corner of my circuit. Here, we connect an Arduino to our square wave circuit. This then connects to a 10K ohm resistor and then connects down to our main line. On the right side, we have the input from voltage or the positive rail of the breadboard through a 1K ohm resistor. And then here, we have the same input from the positive rail of the breadboard leading down to a 1K ohm resistor. And then here we have CC1 and CC2. This is where the square wave signal enters our 14-segment display. We then connect the ground pins on our 14-segment display to CC1 and CC2 as seen here. We have one NPN and one PNP transistor. This leads our circuit to ground seen here through the emitter pin.